We're given a quadrilateral Q. Q is 0, 0, 4, 2, 10, 10, 8, 6. If you did not know already, in a matrix, the top part is X and the bottom part is Y. Okay. And if you did not know yet, this has 4 sides. And how do I know this? Well, first thing is, it's a quadrilateral. Quadrilaterals have 4 sides. 1, 2, 3, 4. And you can have any type of quadrilateral. As long as the shape has 4 sides, that means it's a quadrilateral. I just did the same shape again, and that looks like a triangle. But really, that is a quadrilateral. You just cannot see it. Okay, now let's go back to this. There's another thing that tells me how many sides the shape has, and that'll be the points. We have 4 points. 1, 2, 3, 4. We have 4 points. These points are gonna be plotted in a graph somewhere, and that's what first question says. It says draw its position on a graph. So I'm gonna bring up a graph paper, which you might be given in your lecture. If not, then good luck trying to draw the axis. In my opinion, since they're all even numbers, do it 2 by 2. So you'll start with 0, then 2, 4, 6, 8, 10. But I've got a graph paper, so this is going to be easier for me. Now let's draw this. The first thing you're going to think about is that it gives us a 0 and a 0. That means it starts from the origin. The origin is always in this thing, in this part here. So I'm going to try and bring up this dot. Okay, this is our first dot, because it's a 0, 0. You always start with X, so X0, Y0. Second part is 4, so X equals to 4 and Y equals to 2, so you go 2 up. This will be our second point. The third point is 10, 10. So you go up to the X where it says 10, and then you go all the way up to the other 10 on the Y axis. And that will be our third point. Last point is 8, 6. So we go up to 8, and then we go all the way up to 6. Okay, so to not confuse anyone, I'm going to remove this from the side. And now we got our 4 points from our quadrilateral Q, but that's not what we want. We want to draw its position on a graph, and it's a quadrilateral, so that means it needs 4 sides. Right now we only have 4 points. So just join the points together, and at the end of that you should have a quadrilateral drawn on your piece of paper. And yes, we do. This is quadrilateral Q. It's also good practice to always include the name, which is in this case is Q. Q is the name of this quadrilateral. So that's pretty much it. Okay, now the question asks us to draw its position after transformation. To do this, we first got to transform Q into W, V, and U. And then we got to keep to describe the effect of each transformation. Okay, to do this, the first thing we're going to do is multiply Q by the given letter. So we're going to have something like Q times W, and this will equal to the transformation. In this case, we're doing W and Q. So before we do this, you gotta put this side before Q. So it's not really Q times W, it's the other way around. It's W, Q that we're trying to find. So this will be 0, 1, 1, 0, and then we have Q 0 0 4 2 10 10 8 6. To multiply in the matrix, we gotta do a row times column. So remember this. RC is very important when we talk about matrices. So we put RC there, so we remember that it's R. So R is column times, R is row times column. And then we have our new equation, and we're going to work it out. Hopefully it won't look too bad. So the first thing we do is times 0 by 0, that gives us 0, and that'll be 0 plus 1 times 0, so that'll be 0 at the top. And then we do the second row, times the column again to get the second value, so it's gonna be 0 as well. 0 times 4 is 0, 1 times 2 is 2, so that will be 2 at the top. 1 times 4 is 4, 0 times 2 is 0, so that will be 4, because 0 plus 4 is 4. Now we have 0 times, well, if you notice the patterns, they're kind of just the inverse of each other, and there's 10 and 10, so that means the result is always going to be 10 and 10, because these numbers are just flipping over themselves because of this transformation here. Okay, so 0 times 8 is 0, 1 times 6 is 6, so that will be 6 at the top and 8 at the bottom, like I just said. And this is our W. This is our graph W. So what does this graph do? Let's find out. We'll remove Q from there, and we'll bring down a copy of the graph we did earlier. Just position it on the graph again. This is the graph we want. This is Q. Now we're going to draw W in it. So to draw W, we just got to do the points first, like I did before. So 2 to the 0 0, so there's also an origin, and then we have 2x 4y, so 2 4. And this is our second value. And now we have 10 10 again, so it's up here, and we have 6 and 8, so this is our second value. So we gotta just join the values together, and we get our new graph, our graph W. This is W. Now, what can I tell you about this transformation? This basically is a reflection on the x equals to y axis. Let's do the next question. Let's find the values for the other ones before we continue. So let's do B as in a pink color. Okay, so I'm not gonna work through this one, you can do it yourself. V will end up being 0 0 minus 2 4 minus 10 10 minus 6 8. So this is V, and let's draw V first then before we continue. So minus 2x and then positive 4, yes, it's a positive there. Okay, and then it's minus 10 10x, so minus 10x all the way there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it all the way up to 10 as well, which is there. Yes. Okay, now we go minus 6 and then 8. Yes, over here. And obviously we have the origin as well. So let's join the dots together. And there it is, our graph B. So, what's the transformation? Well, the transformation for V is actually 90 degrees anti-clockwise rotation. So, rotate 90 degrees anti-clockwise, and this is a transformation that V did. It rotated the graph 90 degrees anti-clockwise. Let's just continue and do the last part. So let's work with let's do black now for U. So U equals to, U is 0, 0, because if you divide 0 by 2 you always get 0. And then we have 2 and then 1. So you remember we have a 4 and a 2, now it become 2 and 1. And then we have a 5, 5, and a 4, 3. Okay, now let's plot this graph. It starts at 0 and 0, and then we go 2 to the x and 1 to the y. So it goes there. This is our first point. And then we go 5 to 5, which is there. And also we go 4 and then 3. As you can see, we got a very small graph from there. Now let's join the dots so that you can see the difference. It is the same graph, just a bit smaller. And this is U. Now, what's the transformation? The graph was resized to half its size. That would be a good explanation, in my opinion. It tells the reader what happened, and it's true, because that's the value of U. Okay, and that's it for now. Okay, and we are back to this question. Now part C says, draw its position after application of the vector m equals to -5, -5, and describe the effect of translation vector. Okay, so now when we deal with vectors, we do something different. We have vector m equals to -5, -5. Now this means when the graph will move to -5, -5. And remember, this is x and this is y. So now the q will be moved with the vector m. So m will move q. This means that the values of q will all change. So where we have 0, we have to put -5, because -5 plus 0 is -5, and then we have -5 plus 0 as well at the bottom, so we get -5, -5, and then we go -1, and then -3, then we have 5 and a 5, and we have 3 and 1, and this is our new value of q. Now we gotta draw its position after application of transaction vector, so m. let's do that then. Let's get a pen. Let's use a red pen this time, like we did in the first part. Okay, so Q has different values now, and this would be minus 5x, and then minus 5, and this will be the new origin. This is where 0, 0 used to be. So this is our first point, and then we have minus 0 and then minus 3. Minus 0, minus 3. We have 5 and 5 next as our third point, and then we have 3 and 1. Now, like we always did, let's join up the points. And there it is. This is how the graph of Q with application of transaction vector M looks like. So let's write about it. Vector moved along X and Y axis. That's what it did. Moved along X and Y axis. Every X value had minus 5 taken from it, and every Y value had minus 5 taken from it as well. So this is basically what happened. Now, a vector is a line. A vector is not a matrix. A vector is the sort of matrix. A vector has a direction. This is a vector that goes positive. Now, this is a vector that goes negative. So this vector starts from one side and from top ends at the bottom, and it goes diagonally to that side, which was what happened with Q. So remember, vectors have a direction, and you'll realize that's what happened to our graph. Our graph was up here, and it was moved down in a diagonal arrow that goes to minus 5y minus 5x. And that's it. That concludes the question number 1. Thank you for watching.